Hello, we're now wanting to find the equation of an ellipse and write that equation in standard form. In order to do that, the first thing I need to do is determine which standard form I use. Basically, where is the a squared located? Which means I need to know the orientation of the ellipse. So I'm given an ellipse here, some information. The center is -6, 1. I'm told that the minor axis is vertical. So if the minor axis is vertical, the major axis is horizontal, and my ellipse is elongated left and right direction. From there, that gives me my first piece of information is what is the standard form that we're going to use. So that tells me if the major axis is horizontal, then the a squared, or the larger number, goes below the x. Okay, so all I need to know is hk and a and b, and I can write the standard form equation of any ellipse. Okay, so I'm given the center, which means I know that h is -6 and k is 1. So I've got those two covered. And we can fill those in as we go. So that becomes x minus -6, which of course you can switch that to x plus 6. And then that's y minus 1. All right. And so then I need a and b. Well, we were told that the minor axis is 10 units long. So that basically means if we're going through the center here, and the shorter axis is the minor axis, we're saying from end point to end point is 10. And we know that we use b to find, or b is the distance from the center to the end points of the minor axis. So that tells me then that 2b is equal to 10. So that means that b is 5. Okay, so I can put that in my standard form. B is 5. Okay, so now all I need to know is A. Well, I haven't been given anything about the length of the major axis. That would help me with A. But I've been given this piece of information over here, that C is 4. So I've got B, I've got C, and I need to find A. I can use my equation that relates those two values, those three values, excuse me. I know it's a squared, c squared is a squared minus b squared. Okay, so if we just substitute in and solve for a, then we've got what we need. So c is 4, so 4 squared is equal to a squared minus 5 squared. So if I solve that, I get a squared is 16 plus 25, which is 41. So a is the square root of 41. Let's back that up for a second. We need to talk about something here. Let's think about that. I actually just need a squared, but I could find a and then square it, but that's just an extra step. So in this situation, I really want a squared, which is 41. If I find a, I would need a for graphing. So if I found a would be the square root of 41, but then I would have to come over here and square it. So if I'm just writing the equation, I really want a squared and b squared. So I know a squared is 41. Okay, so all I have to do is pretty that up a little bit, and I've got the standard form equation. So it becomes x plus 6 squared over 41 plus y minus 1 squared over 25 equals 1. So this would be the standard form equation of the ellipse that had those given features that we started with. Okay, let's do another example. This one's a little trickier. It requires us to use the definition of an ellipse. Okay, so I know a couple things. I know the foci. 0, -3, and 0, 3. So my foci are located on my y-axis. I always recommend that you draw some sort of a sketch. And some of them we need a more detailed sketch than others. This is one of the situations where I'd recommend to draw something a little more detailed. Okay, so I have a focus point up here, and its coordinates are would be 0, 3, so it's 3 units up. And then I have a focus point down here, which is 3 units down. So its coordinates are 0, -3. Okay, so just knowing the focus points, the location, tells me some very important things about my ellipse. Number one, if the foci are located on the y-axis, then it tells me the orientation of my ellipse, and it has a vertical major axis, so it is elongated up and down. Okay, that will help me with the location of the a squared in the standard form. So let's put that on here. Oh, wait, let's not do that yet. Okay, the other thing that tells me then, or two other things it tells me, is that the center is at the origin, because the center is always the midpoint between the foci. So here, my center point is 0, 0. So that's the second thing it tells me. All right, which that means that my h and k are both 0. So I could say that I can just start with the standard form with x squared and y squared because it is centered at the origin. Okay, and I know then the orientation is my major axis is vertical. My vertices are at the endpoints. So that means the a squared, the larger number, goes below the y squared. Okay. So here's the standard form I need to fill in. I've already filled in the HK, the center. Now all I need are A and B, or A squared and B squared. All right, what do we have? The other piece of information I have is I know that C, so not C for the center, but C, the distance from the center to each focus point, is 3. Okay, well, I don't need C for my standard form, but that might come in handy as we saw in our last example. So I do know that the value of C is 3. Okay, now here comes the other piece of information. I need something else. I have a point on the ellipse. So let's locate that point, which is at 8, -3. So I've got this point here that is actually on the curve or on the ellipse itself. Okay. Another thing I could say then, okay, this is not drawn to scale, but if you want a visual, means my ellipse is something like this. Definitely not drawn to scale. Do not think that. Okay. Now, here's where it comes in. The definition. We said the definition of an ellipse is that any point on the ellipse, or every point on the ellipse, if we calculate the distance from that point to each of the focus points. So if I calculate this distance here, I'll call that D1, and the distance from the other focus point to that point, I'll call that D2. I know by the definition that the sum of those two distances is constant. And the idea is that the sum of those two distances is equal to the length of the major axis. Okay, so D1 plus D2 is equal to 2A, which is the length of the major axis. So if we can come up with those distances, then we have A, and then we can find B using the value of C. So from my picture, just by looking at it, the distance from 0 to over here to 8, so I can tell that D1 is 8. Okay, I know this is a right triangle, and I know that the distance to each focus point is 3, so the other leg of my right triangle then is 6. So sometimes I like to just come out of that messy picture and draw my right triangle without some of that stuff cluttering it up. So I know this is 8, I know this is 6, and so I need to find D2, which can be done with Pythagorean theorem, or I can see that this is a enlarged version of one of my popular right triangles, a 3, 4, 5. But you could use Pythagorean theorem, and we know that 6 squared plus 8 squared is D2 squared, or call it D. So 36 plus 64 is 100. And I know then that D2 is the square root of 100, or 10. So basically, if I have a 3, 4, 5 triangle and we double all of them, it gives me 6, 8, 10. All right, so now I can come up with 2a because I know these two distances. So this one is 10. So I have 8 plus 10 is equal to 2a. Length of the major axis is twice a. So I know that the major axis is 18, which tells me that a is 9. Okay, so I could put 9 here in place of a and then square it. Okay, now I need one more thing. I need to find b squared, and that's where we use c and a, and we find b squared. So lots going on here. So let's find our b squared. So c squared is a squared minus b squared. So we have 3 squared is equal to 9 squared minus b squared. So I end up with, let's do it this way. Basically, this is 9 equals 81 minus b squared. So b squared is 81 minus 9, or 72. And once again, I don't need b unless I'm graphing. I just need b squared for my equation. So I can substitute in, and I know I have x squared over 72 plus y squared over a is 9, so 9 squared is 81 equals 1. And there's my standard form equation. So this one's tricky because it relies on the fact that we know the definition of an ellipse, that any point on the ellipse, if I add up the sum of the distances from that point to each focus, I will always get the length of the major axis.